So in this video we're looking at balancing chemical equations, and our learning intentions are to understand how to balance chemical equations and to state the law of conservation of mass and the law of conservation of matter. So when it comes to chemical reactions, we can represent them using chemical equations. So it can be done in two ways. So the first way is by a word equation, where you label each of the reactants and products by their word. The second way, which is the more common way in li3 chemistry, is using a chemical equation, where you use chemical formulae to represent your equation. So for example, carbon here becomes C, oxygen becomes O2, and carbon dioxide then becomes CO2. In a chemical equation, reactants will always go on the left-hand side, and the reactants are your starting substances. So it's what you begin your reaction with. The products then are the finishing substance, or the substance that is formed, and they always go on the right-hand side. So for balancing equations, we're going to look at two definitions, and these are important just for an understanding from a scientific point of view. So the law of conservation of mass states that the total mass of the products of a chemical reaction is the same as the total mass of the reactants. So that basically means as a reaction proceeds, we don't lose any of the mass that is present in the reaction. The second definition is the conservation of matter, and that basically states that the law of conservation of matter states that any chemical reaction, matter is neither created nor destroyed, and it can only be changed from one form to another. So this is very similar to our law of conservation of energy that you would have learned in junior cycle. When balancing chemical equations, there is a series of steps that you can follow to make them easy for you. So you can count the number of atoms of each element present at the start. Adjust the numbers in front of your molecules accordingly, so you will only ever adjust the numbers in front, never within a molecule. And then it's always important to check the numbers of atoms that they balance at the end. So let's try some examples. So this example here says balance the following equation: HNO3 plus CaOH2 plus CaNO32 plus H2O. So what I always find very handy to do is at the bottom of our equation to write out everything that we have. So this would link with step one of the steps that I just done on the previous slide. So I have a hydrogen, a nitrogen, and I have 3 oxygens. I then have a calcium. I now have 2 oxygens because it's OH2, so there's 2 OHs. So I have 2 oxygens and I have 2 hydrogens. So that is all of the reactants done. So now let's look at the products. So again, I have a calcium. Now, this NO3 is by 2, so that means I have twice of the NO3 present. So that would mean I have 2 nitrogens, but it will also mean that I have 6 oxygens. 1, 2, 3 for the first NO3, and 1, 2, 3 for the second. And then that's followed by H2O, so I have 2 H's and an oxygen. So what I always say now is it's easy to now see how we can balance our equation. So we have a calcium on the left, and we have a calcium on the right. So that means that we are happy with those. The next thing to look at would be there is 1 nitrogen on the left, but there is 2 nitrogens on the right. So that must mean that I need 2 HNO3 to give me my 2 nitrogens on the left-hand side and my 2 nitrogens on the right-hand side. So that is the nitrogens taken care of. But because I now have 2 HNO3, that means that I have added an extra hydrogen and 3 extra oxygens. So if I look on the left-hand side, I can see that I have 1, 2, 3, 4 hydrogens present, and I have 1, 2, 3, 4, 5, 6, 7, 8 oxygens. If I look at the right hand side, I can see I have 2 hydrogens and 7 oxygens. 1, 2, 3, 4, 5, 6, 7. So if I have 2 hydrogens on the product side and I have 4 on the reactant side, I need to get 2 extra ones here on the product side. So it would make most sense to do plus 2H2O, because if I have 2 waters, then that adds a H, and an O to make up 2H2O. And now if we look, our equation is completely balanced, because our 4 hydrogens can cancel out with the 4 hydrogens here, and our 8 oxygens can cancel out with the 8 oxygens that are on the product side. So that means that your CaOH2 will remain the same, and your CaNO3 will also remain the same. So it's just the 2HNO3 and the 2H2O that has changed to balance that equation. So here I have completed step 2 and step 3 in the one go, as I have balanced my equation and I have also checked. So let's try another example. So this example says balance the following chemical equation. BaCl2 plus Na2SO4 goes to NaCl and BaSO4. So as I did the last time, the easiest thing to start with is to write out each atom that is present clearly. So I have a Ba, Cl and Cl because it's Cl2, and with that I have 2 sodiums, I have a sulfur, and I have 4 oxygens coming from the O4. Then on the product side I have 1 sodium, 1 chlorine, 1 barium, 1 sulfur, and 4 oxygens. So now let's get to work on balancing the equation. So it's very evident straight away that I have 2 chlorines on the left hand side of my equation, but I only have 1 chlorine on the right hand side, or the product side. So that would tell me straight away that I will need 2 NaCl, because that will give me the extra chlorine that I need to keep both sides of the equation balanced. So I can see now that I have a chlorine and a chlorine, a chlorine and a chlorine. I can also see that I have a barium and a barium, so they can cancel out. And if we actually look, I see that I have 2 sodiums on the reactant side, 2 sodiums on the product side, 1 sulfur on the reactant side and 1 sulfur on the product side, and I have 4 oxygens on the reactant side and 4 oxygens on the product side. So that simple change has actually balanced my equation. So my equation is BaCl2 plus Na2SO4 goes to 2 NaCl plus BaSO4, and that is that equation balanced. So if I was to give you one piece of advice with balancing equations, it will be to write out each of the atoms present in your balanced equation and work with the ones that are present in the smallest quantities first. So obviously the bariums were here, but the sodiums were very obvious that there was a mismatch with my sodiums. So that's where I went to first, and the equation worked out for me from there. So it's important to write these out and try and spot